So we need to rewrite this expression in terms of x and y only. We can't use trig expressions. So notice what we have here. We have a composition of trig functions with inverse trig functions. And the idea was that inverse trig functions, they just stand for angles. So this sine inverse of x should equal some angle. I don't know what that angle is. Let's call it theta. But I do know one thing about this theta. I do know that sine inverse of x equals theta such that the sine of that angle is x. Same thing with the cosine inverse of y. I know he should equal some angle. I don't know exactly what that number is, but I know it's going to be some angle. Let's call it phi. But there's something special about this phi. I know precisely that if I take the cosine of this phi, that should equal the original y. Well, when you have trig ratios, now you're probably thinking to yourself, these aren't ratios. Well, you can always make them ratios by putting it over 1. The idea is that when you have trig ratios, you can just simply draw triangles. So, knowing that sine of theta equals x, that means in a right triangle, if I have theta somewhere, I know that the sine opposite over hypotenuse is x over 1. And then using Pythagoras' theorem, I know that the remaining side is 1 minus x squared. Similarly, for if I know that cosine of phi equals y over 1, that means if I have a right triangle with an angle phi labeled, I know that his cosine, adjacent over hypotenuse, is y over 1. And then through Pythagoras' theorem, the missing side is 1 minus y squared. So now I can answer the original question, because sine of sine inverse of x plus cosine inverse of y is simply sine of this theta plus that phi, because that's what cosine inverse and sine inverse of x and y are. So this is equal to sine of theta plus phi. Remember, sine inverse was theta, cosine inverse was phi. Well, this is just a sums identity, right? We do have the sine of a sum formula. And according to the sine of the sum formula, that's sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. Now, to figure out these sines and cosines, you just look at the complete picture. So we can just simply see sine of theta using the theta triangle, that the sine is x over 1, or simply x. Times cosine of phi, using the phi triangle, we can see that the cosine is just y. Plus cosine of phi, we can look at the phi triangle, see that the cosine is the square root of 1 minus y squared, times the sine, should be cosine of theta. Cosine of theta, sorry. We can see that the cosine of theta is the square root of 1 minus x squared, times the sine of phi, which is the square root of 1 minus y squared. And then, since they're both two radicals multiplying each other, you can put them within one radical. So that should have been the solution.